Very good day to all of you. We are going to continue our previous video on solving applications of differential equation in electric circuit using Laplace transform. Okay, this is the second example. Our previous example is actually we have the RL circuit, and the ET is a continuous function, exponential functions. Now we have the RLC circuit, and the ET is a non-continuous function. Okay, so we have our RLC circuit with the inductor 1 Henry, resistor 2 ohm, okay, capacitor is 0.1 farad. The ET, actually a power series of 100 units, is applied to the circuit for 8 seconds only. Okay, we want to find the current IT and the RLC circuit, which is initially at rest. So means I0 equal to 0. So taking the voltage Kirchhoff voltage law, we have the VL is the voltage across the inductor, VR voltage across the resistor plus voltage across the capacitor. So inductor, resistor, capacitor equal to the supply voltage. Okay, supply voltage here ET. And then voltage across the VL is L dI/dt, VR is IR, VC 1 over C integral of I tau d tau from 0 to t. Okay, ET because power series of 100 units is applied to the circuit for 8 seconds only. So mean ET equal to 100 for t less than equal to 8. Okay, when t greater than equal to 8, the voltage becomes 0. It's hold for 8 seconds only. So the voltage here is a non-continuous function compared to our previous video. The ET is a continuous function of exponential function, and the previous video is RL circuit only. So to solve this first order differential equation consists of the non-continuous function in terms of the step functions. We can first step we plug in the L value. L is this case L is 1, so 1 dI/dt, R is 2, so 2I, C capacitance value is 0.1, so 1 over 0.1, so you have this is actually 1 over 0.1, or it's actually 10, 1 over 0.1 you get 10, so 10 integral of I tau d tau from 0 to t, okay, and this one convert it from step function to unit step functions. Remember here, from step function convert to unit step function. Okay, factor out the top function g1, takes the bottom, deduct the top, g2 minus g1, the discontinuous point at t equal to a, so multiply by ht minus a. From the step function, if we convert the unit step function, it becomes gt is g1 plus g2 minus g1 ht minus a. Hence, this case, the step function, when you convert the unit step function, you have 100, and then 0 minus 100, you have minus 100. This continuous point at t equal to 8, so it's ht minus 8. Okay, after that, you can take the Laplace transform at both hand side. So Laplace transform for dI/dt, you get s is minus I0. Okay, callbacks here. Laplace transform for yt, you get ys, so it will be is. It you have is. And then I prime t, you have is minus I0. So is minus I0. And then Laplace transform for 2i, you have 2is. Okay, and then Laplace transform for integral for 10. When taking Laplace transform for 10 times of integral I tau d tau, Okay, remember we have learned the Laplace transform of integral. Laplace transform for integral. Look back here. We call back Laplace transform for integral of fu du from 0 to t, you get is fs over s. Hence, if you have a Laplace transform for I tau d tau from 0 to t, you get is over s. Or in our list of formula that we have, Laplace transform for f tau d tau from 0 to t, you have fs over s. So Laplace transform for I tau d tau from 0 to t, you have is over s. Hence, for this one, Laplace transform for I tau d tau by Laplace transform of integral, we have tan is over s. Can you see that? So Laplace transform for integral I tau d tau, you get is over s here. And then Laplace transform for 100 will be 100 over s. Laplace transform for 100 times ht minus 8 will be minus 100 exponent negative 8s over s. Recall back the Laplace transform for Heaviside unit step function. ht minus a, you get exponent negative as over s. So ht minus 8 will be exponent negative 8s over s. This one. Recall. Laplace transform for di dt s is minus I0. So Laplace transform for 2is. Laplace transform for 10 times I tau d tau is 10 is over s. Laplace transform for 100 is 100 over s. Laplace transform for minus 100 ht minus 8 is minus 100 exponent negative 8s over s. Second step, substitute the initial condition. How's the question says, which is initially at rest. So I0 equal to 0. So I0 equal to 0. Hence, left s is plus 2is plus 10 is over s. The right hand side is still the same expression. And then, after we plug in the initial condition, we solve. The third step is actually solving for is. We factor out the is. So a bracket. First term we have s. Second term here is 2. The third term 10 over s. Right hand side still maintain. And then for this term we compose as one fraction by making the same denominator over s. So first term you divide by s, you multiply by s. So s times s, you have the s squared. Second term you divide by s, you multiply by s, so plus 2s over s. And the third term is 10 over s. And you notice that later on you notice that with this left side, right side, you have the same denominator, which is over s. So you can cancel the denominator at both hand side. And then we want to solve for is. Hence, the term s squared plus 2s plus 10 you bring to right hand side become 100 over s squared plus 2s plus 10. Minus exponent negative 8s over s squared plus 2s plus 10. You notice that s squared plus 2s plus 10 in this case cannot be factored as multiplication of two factors. However, it can be done using completing the square. So completing the square here, we have 1s squared. So you open a bracket s. So this is 2s, positive 2s. So it plus half of the coefficient of your linear term, half of it. So plus 2, you divide by 2, so plus 1. You close the bracket, you square it. You try to expand back, you should have s squared plus 2s plus 1. Plus 1. Initially plus 10. So totally, you need to plus 9 more. I repeat one more time how you do the completing the square. To do completing the square, make sure the coefficient for s squared here is 1. Luckily, this is 1. So you open a bracket. So this is s. And then you look at the linear term plus 2. You divide by 2 all the way. divide the coefficient of linear term by 2. So positive 2 divided by 2, you get plus 1. Close the bracket, you square it. And try to expand back. You will have what? Okay, this is s squared. So 2 times 1 times s, so you get 2s. Then plus 1 squared, so 1. Initially you have 10. So you need to plus 9 more. Okay, that's how we do the completing the square. If we cannot factor out that quadratic term into 2 linear factor. So same with the second term here. So it becomes minus 100 exponent negative 8s over s plus 1 squared plus 9. Okay, fourth step, taking the inverse Laplace transform. Okay, taking the inverse Laplace transform, you'll get here 100 over 3 exponent negative t sin 3t for the first term. The second term comes negative 100 over 3 exponent negative t minus 8 sin 3 times t minus 8 ht minus 8. Okay, how we get this one? We call back how we do. Okay, first term you need to use first shift property. Second term you need to use second shift property. Okay, look back. Okay, for the first term. Okay, first term, how you do the inverse Laplace for 100 over s plus 1 squared plus 9 and obtain this result for first term. Okay, recall back. Okay, if you first shift property, if Laplace transform for exponent at ft, the result is fs minus a. Hence, the inverse Laplace transform of fs minus a, the result will be exponent at ft. Hence, you compare here, this one, 100 over s plus 1 squared plus 9. You notice that this is actually in the form of fs minus negative 1. Okay, this is in the form of fs minus negative 1. Right. So if fs minus negative 1, using first shift property, the inverse Laplace transform you should have, because a is negative 1, the result you should have exponent, if a is 1, exponent negative t, ft. Okay, ft, how you get ft is actually inverse Laplace of your fs. Okay, how you get fs? Okay, fs means the s, okay, plus 1 here, you just replace back by s. So mean, okay, this is exponent negative t, ft is the inverse Laplace of your fs. fs, s plus 1 replaced by s. So this is the inverse Laplace of 100 over s squared plus 9. Okay, and then, okay, you can factor out 100. Then you notice that s squared plus 9, so numerator you must have 3, so that the inverse Laplace of 3 over s squared plus 9, you can get sin 3t. So you multiply by 3, you have to divide by 3. That's why the result, okay, you have 100 over 3 exponent negative t sin 3t, which is here. Okay. 100 over 3 exponent negative t sin 3t, where you obtain it using first shift property. The inverse Laplace transform of fs minus 8, in this case is fs minus negative 1. The result is exponent negative t. Okay, ft is the inverse Laplace of your fs. Fs means, okay, s plus 1 change back to s. Then inverse Laplace of 100 over s squared plus 9, you get, okay, sin 3t over 3. Now factor out 100. Okay, the second term is actually similar with the first term. However, the second term is exactly similar. However, is multiplied by exponent negative 8s. Right? With the second term, you have the form of actually fs exponent negative 8s. Once using the second shift theorem, which says that the inverse Laplace of exponent negative as, so in this case your a is actually, a in this case is 8. The inverse Laplace of exponent negative 8s, fs, the result is ft minus, you should have the result ft minus 8, ht minus 8. ht minus a, right? Where the fs, this is the fs, this one is the fs. Right? In the inverse Laplace of this term, so you have f, okay? The result is ft minus a, ht minus a, where the a is a. So to get ft minus a, okay, you must get your ft first. Okay, the ft. To get ft, identify your fs. Okay, and then the fs is actually fs similar to here, and obtain this is actually the ft, right? Because fs 100 over s plus 1 squared plus 9. Okay, you're taking the inverse Laplace of this fs, you obtain this is the ft. Hence the ft, the result for 100 times exponent negative 8s over s plus 1 squared plus 9, the result is ft minus 8, ht minus 8. That's why from the ft they obtain in the first term, t here you replace by t minus 8, then sin 3t, t here replaced by t minus 8, and then multiply by ht minus 8. That's why here. That's why you look here, because first and second term actually differ by here. This is the fs. Using second shift property, you should get the result ft minus 8. So have your result is ft minus 8 multiply ht minus 8. So ht minus 8. ft minus 8, where the ft obtained from the first term, 100 over 3 exponent negative t sin 3t. T minus 8 and ft minus 8. So the t here replaced by t minus 8. Okay, so that's why. So this is okay for the application of differential equation in RLC circuit, where the et is a step function. Et is step function, it convert to unit step functions, and then we take the Laplace transform at left hand side, and the new thing, okay, for the VC, okay, by Kirchhoff voltage law is 1 over c integral of I tau d tau from 0 to t. Taking the Laplace transform of integral, we have and c here is 1 over 0.1 become 10. Then taking Laplace transform of 10, integral of I tau d tau from 0 to t is actually 10 is over s. This is a new thing here. And then second step, plug in initial conditions. Third step, taking solve for the is. After plugging in the initial conditions, solve for the third step. Last step, taking the inverse Laplace transform. Okay, taking the inverse Laplace transform. First, okay, you have two terms here. First term, we solve it using because the s squared plus 2s plus 10 cannot be factor as two linear factor, but can be done using completing the square. Hence, we solve the first term using first shift property. Okay, second term is actually similar with the first term, only multiplied by exponent negative 8s. Exponent negative 8s, hence is in the form of applying the second shift property. In first term, you need to apply first shift property here. That's in the form of fs minus a. Normally, if you do the completing the square, your function fs will in the form of fs minus a. Hence, fs minus a, to find the inverse Laplace transform, you need your first shift property. You get will give you exponent at ft, and then for the second term just now is in the form of, let's found the second form. Second term is in the form of first term the second term the fs same with the first term, only multiplied by exponent negative 8s. So the result is ft minus 8 ht minus 8. It takes ft from the first term, so t replaced by t minus 8 multiplied by ht minus 8. Okay, So that's why if we got the result for first term is here, the second term, okay, this is Fs, apply second shift property, we have Ft minus 8, so the t here replaced by t minus 8, multiply Ht minus 8. Okay, with this, okay, thank you for your attention and watching this video.